In this tutorial, I'll show you how to design a RC low pass filter. Okay, for that we need R and C, and we'll find it under electrical element. This is our capacitor C, and this is our inductor. Sorry, resistor R. Okay, and we need a source, electrical source, which is control voltage source, and obviously we need PS Simulink PS and server configuration, and under electrical element we need electrical reference, and sensor, obviously we need voltage sensor. Okay, so that's all I need. And now let's connect this, and capacitor is here, and okay, this is electrical reference and server configuration block. Okay, and we need to measure output voltage here, and we need a scope. This is our output. Okay, and now we have to vary frequency for this. For that I am taking a simple MATLAB function. Function then like as frequency sweep. Okay, and our input is t, and let initial frequency f0 equals 400. Okay, and k let 60, and frequency equal f0 plus k multiplied by t, and then for correct phase for linear chart we need a phase equal twice by f0t plus here k will be multiplied by divided by 2 and multiplied by t square. Okay, okay, and finally y is plate amplitude is 20. Okay, this is multiplied by sine phase and our output is y as well as frequency. Okay, and the input will be Simulink clock. Sorry, clock, and y will be connected through Simulink PS converter. And let's take from and go to block. Okay, frequency, and this is our frequency. Okay, frequency. Now we have to choose our resistor and the capacitor value, and I have already made a MATLAB script. My resistance value is 4.7 kilo ohm, and C is 47 e minus 9. And if I run this script, you can see the frequency should cutoff frequency should 720. Okay, so R is our 4.7 kilo ohm. Okay, and C is our 47 nanofarad. Okay, let's check it again. 4 e minus 9. Okay, it's okay. Okay, Now take a larger frequency. You can observe it more clearly. Run this model. Now you can see here the voltage is decreasing as frequency is increasing here. Okay, and now this is the behavior of the low pass filter. Okay, and this will pass the low pass signal, and this will block the high pass signal. Okay, high frequency signal. Okay, so this is the way you can model your low pass filter and check verify it, and you can also code here to find the accurate cutoff frequency here. Okay, so that's all for today. Thanks for watching. Okay.